All right, so go to the page, what did I say, 18. And that's just a quick little review of what we did Friday, adding and subtracting, multiplying with vector or with complex numbers, but we haven't done anything yet with vectors. All right, so if we go to that, let's see here. Page 18, view, shrink. Right here. Okay, zoom in, zoom in. Okay, so we're doing these just arithmetically. Okay, that's what we did yesterday or Friday. So if we're adding and subtracting, you're adding and subtracting the real number part and the whole number or the imaginary part. Okay, so if I was just adding this up, I'm going to take these two terms. Okay, so I've got -4 plus -1, and I'm going to add then the two complex terms, 5i and -2i. Okay, so I end up with -5 plus 3i. Okay, no big deal. Okay, now if I'm subtracting, I can write that as the addition of the opposite. Okay, so if I was writing out my two complex numbers here, so that's 5i. Okay, and when I subtract, I'm really just adding the opposite. So this is -1 plus 2i, whoops, minus 2i, and this is all your assignment was. Okay, and then this is going to distribute through that negative, and it's going to change these guys to a plus and a plus. So now this is just -4, okay, plus 1, plus, and 5i plus 2i. Okay, so we end up with -3, 7i. Okay, now what we're going to do today is these same problems, but do it geometrically. How would you add and subtract them geometrically? All right, let's see, z plus 2w. So I got z, -4 plus 5i plus 2w. So that's a scalar multiplier. It's going to make this twice as long. Okay, and now I'm going to have plus, I got -2 minus 4i. I'm just distributing, just like old-fashioned algebra. Okay, then I got like terms, -6, like terms, 1i. All right, and then z minus z plus 5i minus 4i plus, whoops, 4 plus 5i. And we're just subtracting those guys. So I can change that to a plus, which is going to make that a negative, and make that a negative. Here, I'll write it like this so that I got all the steps in there. minus negative 4i plus 5i. Okay, and then we distribute. Let's see, is this a plus or minus? Plus. Okay, so then we'd end up with this. And then this would be plus 4, and this would be minus 5i. So that's 0. 0 plus 0i. It's gone. Okay, so adding and subtracting, you just think of it as like combining like terms. So depending on if you're adding or subtracting, you're going to combine your real components. And then you're going to combine the imaginary components. So pretty straightforward. Okay, we got that? That's what we did last Friday. Okay, now if we go back to our notes here, what we're going to do is I'll show you how to represent a vector or a complex number using a vector. Let's see. Okay, so this is the first learning target. How do you represent complex numbers as a vector? Okay, so let's say here's where you need to draw yourself a little complex plane. Okay, so let's see, we are going to draw okay, that's why I got the straight edge, so it's a little neat. And then we got, this is our imaginary axis. And this is our real axis. Okay, so what we're going to do is we're going to take the complex number as a vector. So we're going to say complex number z is negative 3 plus 4i. Okay, now the way that we did this on Friday was we graphed the point 3, 4. Okay, so if we wanted to graph where z is, we would just graph the point 3, negative 4, or negative 3, positive 4. Okay, so there's z. Okay, now all a vector is, see, a vector has two things to it, guys. When you hear the word vector, a vector has two qualities. It has length, which is called magnitude. So a vector has a magnitude, which is the same as its length. So the longer you draw a vector, the greater its magnitude. And it has direction. So it's got two qualities to it, magnitude, and then the other quality is direction. So the way that you indicate that is you just draw we used to call it an array when you first learned about it, and that's a vector. Okay, now in this vector, this is called the tail, and where the arrow is, that's called the tip. So the tip is actually where it ends. Okay? That's known as the tip. And that's important because when we start to add and subtract them, we use what's called the tip to tail method when you're lining them up. Okay, now when you see this, let's see, Z, and then like absolute value signs, well, in the world of vectors, that is whatever the length is, or the magnitude. So when I see this, that's equal to the magnitude of Z, vector Z. All right, so how long is that vector? Yeah.
5.
Okay, and how do you get 5?
If you do formula.
The what? A little louder.
If you do like the distance up and the distance across, and the distance across is 3 and the distance up is 4. So you do like if you do 3 squared plus 4 squared,
Which is known as the,
Pythagorean.
yeah, it's just the Pythagorean Theorem. So this is a right triangle, and we know that the length of the hypotenuse is this length squared plus that length squared. Now the negative, guys, just tells you the direction. This length is 3. The negative just means it's going to the left. You can't have negative length, distance. I don't live negative 15 miles from the school. It's 15 miles, regardless of where it is. So the negative just tells you direction. So if I wanted to find the magnitude of this, all I'm doing is I'm taking my horizontal component and squaring it. That's a squared. Okay, that's b squared. And then I want to take the square root of it. Okay, so this is simply going to be 25. And the square root of that's 5. So that's the length of this vector. That's its magnitude. Now, once we talk about learning the direction is going to be this angle here. Okay, but we'll handle that later because we're going to use trig in order to figure out what that angle is. But right now, we just got to worry about the magnitude. Okay? Now, there's another way, there's another type of notation that's also used. Okay? So you might see this. So we have z negative 3, 4i. Okay. It's also might be written like this. It'll say negative 3, 4, and the way you know it's a vector is that it's going to, instead of brackets, it has like these carrots, I guess, arrows. Okay. Okay, and all this is this is your horizontal. And then this is your vertical, or your imaginary part. Okay, and then it's also written as a column. So you might see it written like this, negative 3, 4. Okay, the top number is the horizontal, and the bottom number is the vertical. So it can be written all sorts of different ways. Okay, it can be written horizontally, and it could be written vertically. Okay, questions there? All right, so all we're doing is once we've got that length is simply just the Pythagorean theorem. All right, now, if we want to add and subtract these things geometrically, okay, so let's go back to the notes. You're on page 19 there of your examples here. All right, so this particular vector has got a length of 10, okay? So we got 6 squared plus negative 8 squared. Okay, that's 100, so this thing has a length of 10. Okay, what would other vectors be that have the exact same length? So this vector right here was 6, 8. So let's draw it right here. 6, 6, negative 8. Right there. Okay, so that's Z. And it's got a length of 10. When we do the Pythagorean theorem, 6, 8, 10. Okay, what would be another vector that has the exact same magnitude? Yeah, negative 6 plus 8i. Okay, so negative 6 plus 8i. Okay, now let's see. We'll call that Z2. Okay. Z2, negative 6 plus 8i. Okay, another one. You need 6 more.
Positive 6 plus 8i.
Okay, positive 6 plus 8i. Okay, that's Z3. This one was Z2. All right.
Negative 6 minus 8i.
Okay. negative 6, 8i right there. Let's see, let's go with green. Z4. All right. That was negative 6 minus 8i. Okay, 3 more. Go ahead. 8 plus 6i, so 8. 6i right there. Yes? Okay, that's 8 and that's 6, so yep, that's 10. That's V5. V5, 6 plus 8i. No, 8 plus 6i, right? So we could do all of these by doing the exact same thing. So I could make this one 8 minus 6i. And what would this one be? 6, 7. Negative 8 minus 6i. Okay, let me draw those guys in. Okay, so we got negative 8, 6i, negative 8, positive 6i. It's right there. And then we got negative 8 minus 6i. Right there. Negative 8 minus 6i. Call that Z8. Negative 8 minus 6i. 6i. Okay, and then we got one more. 8 minus 6i. 8 minus 6i, that's Z6. Okay. Okay, there's 3 more. No, 4 more. Yeah.
10 plus 0i.
Yep, 10. Okay, 10. Because you could always write that as 10 plus 0i. And then you'd have 0 plus 10i. And so on. Z11 would be negative 10 plus 0i. And then the last one would be 0 minus 10i. Okay, so what do we notice about all the vectors? Yep, they all have a length of 10, so if we connected the tips, we're going to get a circle with the radius of 10. Okay. Okay, they all have the same length and their tips with radius 10. Okay. All right. So to add two vectors, guys, geometrically, let's see, let's take, let's go back to our notes here. Yes. Yeah. Okay. So now we're going to add and subtract vectors. Okay, and then real quick, let's make another plane here. Real, imaginary. So if we did z is -4 plus 5i, and w -1 minus 2i. Okay, those are the same ones that we did earlier. All right, so if we're gonna, we already did these, if we did the arithmetic wise, if I did z plus w, okay, we already know what it is, we did it a few minutes ago. Okay, z plus w was -5 plus 3i. Okay, now we're going to do the exact same thing geometrically. All right, so if I go back here, let's see. All right, so what you're going to do is first you're going to draw z from the origin. So I'm going to go to my origin and I'm going to do z. So that's 4, 5. 1, 2, 3, 4, 5. So -4, 1, 2, 3, 4, 5. Whoops, that's z. All right, now what you're going to do to add w to it, you're going to go to the end of this and you're going to add w using its components. All right, so once I've got there, then to add w to it, well, w is -1, -2. So I'm going to go 1 left and I'm going to go 2 down. And then that is going to be w. Let's see, I'm adding w. So I attach w to the tip of z. Right? So I did that, and then w was right here. Let's see. Okay, and then this is w. That's w, and that's c. Now you notice how I put that little half arrow on the top? That's just another note, this with the little arrow, not the full arrow, but the half arrow. That just is a vector. that symbol there. All right, so then from there, your answer is from the origin to wherever you finished. That is z plus w.
Caroline, can I get feedback?
Mm-hmm. So that's how you add vectors geometrically. So what we did first was we starting at the origin, okay. We drew vector z. Okay, and then we went to the tip of z, which is right there, the tip of z. All right, and we moved one left, two down. So then from the tip of z, move one left and two down. Okay, and then your answer is whatever the endpoint is. So 3. Okay, the resulting point is z plus w. Question? So that's known as the tip to tail method. And that's how you add vectors. Okay? And if this red vector has the 1, 2, 3, let's see, 1, 2, 3, 4, 5. It's negative 5 and 3i. So this is negative 5 plus 3i. Now to subtract them, all you do is add the opposite. Okay, so if I wanted to subtract these two, you're going to think of this as z plus the opposite of w. All right, so you would do it the same way. You draw z. Okay, and then what's different now, from the tip of z, tip of z, you're going to move, okay, well, you're going to go the opposite. So now you're going to go one right and two up. That's the opposite of W.
So it would be -3 plus 7i?
Sounds about right. Okay, so if I did that, I'm going to go, let's see, one right, two up, right there. That's negative W. And then this would be this is called the resultant. That would be Z minus W, which is, let's see, negative 3, 1, 2, 3, 4, 5, 6, 7. So negative 3 plus 7i. So you can add lots of vectors. You just go to wherever your last tip was, draw your next vector. And then when you're all done, you connect wherever you are with the origin, and that is called your resultant. Okay? So these vectors right here are called resultants. That's called a resultant. This is called a resultant. And it's just the result. Okay, so that's the tip to tail method. All right, so let's try. Can I move it? We got it? Okay, all right. Okay, so now let's do Z plus 2W. All right, so sketch yourself a imaginary plane. What was Z? Z was negative 4 plus 5i. Z equals negative 4 plus 5i, and W is negative 1 minus 2i. Negative 1 minus 2i, and we want to geometrically construct Z plus 2W. Okay, so draw your Z. Negative 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And now you just add W twice. So we're going to go 1 left, 2 down, 1 left, 2 down. 1 left, 2 down, twice. Okay, so let's see. 1 left, 1, 2. 1 left, 1, 2. Nope. Let's see. I lost my direction here. What did I say? 1 left, 2 down. 1 left. Oops. It's hard to do when it's not lined. A lot easier to count. Okay, so let's just make sure I got this right. 1 left. So it puts me at 5, and then 2 down. 1, 2. Okay, so there's 1 W. And then I do it again. 1 left. 1, 2. Are you guys ending up the same place? 1, 2, 3, 4, 5, 6, 1. Yes? -6, I. Yes, no?
Yes.
Yeah? Okay. Are we okay, we're almost out of time, huh? Okay. So, we will finish this up tomorrow. And tonight, guys, let's see. No, we'll do it tomorrow. So for you slackers, do your homework.
Sorry, can you do that the first hour?
You don't have to, just do it, get it done.
Adjustment free. Oh, yeah. Adrian, you good? Watch video next game. Doesn't make you like great essay, like